In this video, we will learn about the breadth-first search algorithm and how to implement it using C++. Let's look at an example using the tree shown here. The tree has a root node with a value of 1 that has a left child with a value of 2 and a right child with a value of 3. The tree has leaves with the values 4, 5, 6, and 7 respectively. With a breadth-first traversal or search, we visit a node's neighbors before visiting its children. So the traversal would start at the root node 1. Then we would visit 2 and then 3, since these two nodes are on the same level, aka neighbor nodes. After that, we visit the nodes 4, 5, 6, and 7. This completes the breadth-first traversal. Now that we understand the concept of a breadth-first algorithm, let's learn how to implement it using C++ code. At the top of the code, we will include the Q header file. After that, we will create a class named node with 3 public properties, an int named value, a node pointer named left, and a node pointer named right. Next, we will create a function with a void return type named breadth-first-search, which takes in one parameter, a node pointer named root. To implement a breadth-first-search, we can use a queue, since queues follow the principle of FIFO, first in, first out. As such, we will have a queue of node pointers named Q. Then we will push the root onto the queue. Next, we will have a while loop that runs while the queue is not empty. Inside of the while loop, we will have a node pointer named n that we set equal to q.front. After that, we will pop the front value from the queue. Next, we will log the value of n to the console. If n's left child is not null, we will push it onto the queue. In a similar fashion, if n's right child is not null, we will push it onto the queue. Next, let's go inside of C++'s main function. We will create some pointers to nodes for each node in our tree. Let's create a pointer to a node named root that we set to a new node. Similarly, we will have a variable named left child, a variable named right child, a variable named left child's left child, a variable named left child's right child, a variable named right child's left child, and a variable named right child's right child, each of which is a pointer to a node initialized to a new node object. After that, we will set root's value to 1, left child's value to 2, right child's value to 3, left child's value to 4, left child's value to 5, right child's value to 6, and right child's value to 7. Then we will set root's left child to left child and root's right child to right child. Next, we will set left child's left child to left child's left child and left child's right child equal to left child's right child. After that, we will set right child's left child to right child's left child and right child's right child to right child's right child. Next, let's output a visual representation of the tree to the console. Then we will make a call to our breadth-first-search function and pass in root. Up at line 11, let's ensure that we add a semicolon after the closing curly brace at the end of the class. I'll also make a couple spacing adjustments to the visual representation of the tree so that the values of the nodes print evenly spaced out. When we run the code, notice that a visual representation of the tree was output, and the breadth-first traversal output the values 1, 2, 3, 4, 5, 6, and 7, in that order, to the console.